Can you imagine a cosmic symphony performed by an incalculable number of stars, planets, and moons, all playing in perfect harmony? Amid this orchestral expanse, there exists a particularly mysterious section that has left astronomers perplexed for centuries: the exoplanets. These are not just distant worlds. They are celestial enigmas that lie beyond our solar system, scattered across the vast depths of the Milky Way. You might be surprised to learn that among the billions upon billions of cosmic objects, there is an exoplanet so uncannily similar to Earth, so tantalizingly familiar yet enigmatic, that it has often been referred to as Earth's celestial twin. This planet is known as Proxima b. Located a mere 4.2 light-years away, Proxima b has become the subject of intense scientific fascination. And with the advent of the James Webb Space Telescope, our search for understanding these alien worlds is undergoing a monumental transformation. Picture your imagination soaring through the colossal expanse of the Milky Way, a galaxy home to more than a quadrillion exoplanets. To put such an incomprehensible number into perspective, imagine 1 quadrillion grains of sand. Not only could they fill the Grand Canyon, but they could create an entirely new geological monument, a Grand Canyon 2.0 stretching across miles. The most astonishing revelation is that nearly 20% of these exoplanets are considered Earth-like in terms of their atmospheric and geological makeup. That means that statistically, 1 in 5 of these planets could potentially resemble Earth. But that's not all. Alongside these planets exists a similarly staggering number of moons, rocky satellites akin to our own moon, engaged in gravitational dances with their parent worlds. If one were to place a bet on the likelihood of discovering another celestial body capable of supporting life, the cosmos offers an almost overwhelming abundance of options. Now that we've opened the curtains on this vast cosmic stage, it's time to introduce the masterful instrument that allows us to perceive its intricate details: the James Webb Space Telescope. Think of it as a celestial Sherlock Holmes, a detective not with a magnifying glass, but with a massive 6.5 primary mirror, 2.7 times larger than that of Hubble. It can detect the faintest flickers of light emitted by stars billions of light-years away and analyze the chemical fingerprints of exoplanets orbiting them. Its revolutionary technology includes cutting-edge infrared sensors and a powerful spectrograph that do far more than observe. They analyze and interpret the complex symphony of cosmic signals. The Webb telescope doesn't merely watch the universe unfold, it deciphers it. Its ability to filter and read the unique light signatures of celestial bodies enables it to determine their atmospheric composition, mass, and even potential habitability. It's no exaggeration to say that the James Webb Space Telescope represents a quantum leap forward in astronomical capability. As we widen our field of vision to embrace this cosmic panorama, our focus narrows once again to one specific star in this galactic showcase: Proxima b. Since its discovery in 2016, this enigmatic planet has taken center stage, not unlike a Shakespearean protagonist, full of contradictions, drama, and tantalizing potential. Why all the fascination? First, there's its proximity to us. Located just 4.2 light-years from Earth, it is essentially in our cosmic backyard. To offer some perspective, if it were possible to travel at the speed of light, a feat well beyond our current technology, you could reach Proxima b in just over 4 years. That's roughly the time it takes for a presidential term to conclude or your favorite TV series to dramatically change course. In a universe that spans over 93 billion light-years from end to end, the discovery of a potentially habitable planet so close to us is nothing short of extraordinary. It's like discovering a rare diamond amid a vast, endless desert, shimmering with promise and mystery. But it's not just Proxima b's proximity that excites the scientific community. It's the compelling possibility that this planet is not just similar to Earth, but could, under the right conditions, serve as Earth 2.0. Proxima b resides within its star's habitable zone, often called the Goldilocks zone, where conditions may be just right for the presence of liquid water, a fundamental ingredient for life. Picture cascading waterfalls, winding rivers, and perhaps even oceans as deep and mysterious as Earth's own Mariana Trench. Yet before we begin planning dream vacations on Proxima b, it's important to consider some of its more peculiar characteristics. For instance, a single day on Proxima b is equal to roughly 11 Earth days. Imagine a sunrise that stretches for hours, a golden dawn that seems reluctant to yield to noon, and a sunset that lingers in the sky like a painted masterpiece. Though beautiful, this has profound implications for climate, weather, and habitability. Would human biorhythms adjust to such long cycles of light and dark? Would our patterns of sleep, eating, and work have to evolve in unexpected ways? On a world like Proxima b, the familiar would intertwine with the alien in perplexing and potentially fascinating ways. You might wonder how scientists can gather such precise information about planets we have never visited. This is where the James Webb Space Telescope flexes its extraordinary capabilities. Far more than just an eye in the sky, Webb acts as a floating scientific laboratory. Its spectrographs allow astronomers to study the light emitted or reflected by distant planets. Every atom and molecule interacts with light in a unique way, absorbing or emitting specific wavelengths. By examining these light signatures, scientists can determine whether an exoplanet possesses water vapor, carbon-based organic compounds, or even oxygen, elements crucial to life as we understand it. This isn't just astronomy, it's forensic science conducted on a cosmic scale. We no longer wait passively for the universe to reveal its secrets. We go looking for them, dissecting photons like digital detectives on a galactic beat. The Webb telescope is the ultimate hybrid of laboratory analyst and cosmic sleuth. Just when it seemed we had unraveled the most compelling threads of this cosmic tale, the story took a dramatic twist, one that would feel right at home in a science fiction epic. Researchers using the James Webb Space Telescope captured a signal from Proxima b that was so unusual, so unlike anything previously observed, that it sent shock waves through the scientific world. Classified as a potential technosignature, this electromagnetic signal exhibited complex and anomalous patterns suggestive of artificial origin. For a fleeting moment, humanity's collective imagination held its breath. Could this be it? Could this be the long-awaited confirmation that we are not alone in the cosmos? And just as suddenly as it had appeared, the signal vanished. It never repeated. What it left behind was a silence so profound it seemed almost intentional, like the echo of a whisper carried off by the wind. Scientists were left with a swirling vortex of theories and speculation. Was this merely a transient phenomenon, a cosmic fluke, or was it something more? Could it have been a deliberate message, a kind of interstellar handshake offered by a distant intelligence? Or perhaps it was the manifestation of some unknown cosmic process, a riddle wrapped in the enigma of stellar physics. Regardless of the answer, the event cast a long and tantalizing shadow over Proxima b, transforming it from a subject of scientific interest into a symbol of one of the greatest mysteries we may ever face. To this day, the mystery of that vanished signal lingers. The questions it raised remain unanswered. Was it a fleeting anomaly, a mistake in our instruments, or a glimpse into a deeper, more complex narrative, one that we are only just beginning to understand? The truth is, the final chapter of this cosmic drama has not yet been written. The ink is still wet. The narrative of our exploration of the stars is an evolving tapestry, and now researchers from Harvard and other leading institutions are stepping in to help unravel the mystery. Their work, combining advanced algorithms, new observational strategies, and deeper spectral analysis, promises to open new avenues in our quest to understand what or who may be out there. In the end, the story of Proxima b is not just about a planet. It is about the way we view ourselves in the cosmos. It is about the questions we ask, the tools we build, and the infinite curiosity that drives us to look up and wonder. With the James Webb Space Telescope, we are not merely gazing into the heavens. We are engaging in a conversation with the universe. And perhaps, just perhaps, the universe is beginning to whisper back. The intrigue surrounding Proxima b has evolved from curiosity into obsession, not only because of its physical properties, but because of what it represents. A mirror held up to Earth from across the stars, offering a tantalizing hint that our planet might not be as unique as we once believed. Scientists and dreamers alike have long speculated on the conditions necessary for life to arise elsewhere in the cosmos. For centuries, we had only theories and guesses. But now, For the first time in history, we have the tools to look beyond the veil with startling clarity. The James Webb Space Telescope has given us a chance to not only dream, but to investigate with scientific precision. Through its powerful instruments, the telescope has allowed researchers to study Proxima B's atmospheric signatures in unprecedented detail. And what they have found, while not yet definitive, has certainly been compelling. The first signs that caught astronomers' attention were subtle chemical traces in the light spectrum, suggesting the possible presence of water vapor and carbon-based compounds, two pillars of organic life. Though no direct evidence of biological activity has been confirmed, these findings alone make Proxima be a prime candidate for deeper study. The implications are staggering. If even one exoplanet like Proxima b can support life, the statistical likelihood that life exists elsewhere in the universe increases exponentially. After all, if nature was able to spark life once on Earth under specific but not improbable conditions, then it may well have done so again on worlds that share similar environments. The universe is not a sterile expanse, but a teeming cauldron of chemistry and potential, where the seeds of life might be far more common than we dared hope. But the mystery does not end with atmospheric analysis or habitable zones. The strange signal previously detected from Proxima b has reignited discussions about technosignatures, those signs of advanced, intelligent civilizations that might manifest as patterns in radio waves, anomalous bursts of energy, or complex electromagnetic emissions. While many scientists are cautious and even skeptical about attributing such signals to alien life, they agree that the very existence of anomalies demands deeper inquiry. The question is not just whether we are alone, but what forms life might take if it exists elsewhere. Would it be carbon-based and water-dependent like us? Would it construct cities, emit signals, or manipulate its environment in recognizable ways? Or would it be something entirely alien, something our human minds cannot yet conceive? Even if Proxima b harbors no life at present, its potential cannot be understated. Some scientists theorize that the planet could be in a transitional state, either in the process of developing life or recovering from a past extinction event. Imagine a world where evolution followed a different path, where unfamiliar life forms once thrived and were extinguished by cosmic or climatic catastrophes. If remnants of such life exist, they could be detected in the planet's soil, rocks, or even the composition of its atmosphere. Studying such a place wouldn't just teach us about exoplanets. It would teach us about ourselves, about the resilience and fragility of life.